Okay, hello everyone. Today we'll just be doing a review of Vertex and Intercept forms and how we can graph quadratic equations in each of these. You'll be working this on your own, but I just wanted to do a couple of examples with you guys to make sure you don't have any questions. So let's go ahead and look at the first one. 1/2 x plus 4 squared minus 7. This is in vertex form. And because it's in vertex form, we can pretty easily find the vertex. We know we're shifted to the left 4 because it's plus 4 on the inside. And then down 7 because it's negative 7 on the outside. Okay, so we graph our vertex. 1, 2, 3, 4, negative 4, negative 7. And then again, I always like to graph the axis of symmetry as well. And then again, our normal pattern will be up 1, up 3, and up 5. But because we have a 1/2 in front, we're instead going to multiply each of these by half. So we're going to use these points. So we're going to go up 1/2, and up 1.5, up 2.5, and there it is. So that is vertex form. And then let's now look at an example of intercept form. Let's actually go over here with h of x. So this is my equation that I'm working with. This is written in intercept form. Okay, and then how do we find the intercepts? Because we'll need those to find the vertex, right? We can just set this equation equal to 0, and then we see that our intercepts are going to be at 4, 0, and 6, 0. And then if you remember, to find the axis of symmetry, we're going to take the average of our intercepts. So we add them up, divided by 2, we get 5. So that tells us the x-coordinate is 5. And how do we find the y value? Well, we can just plug in x equals 5 into our equation. So I'll get 5 minus 4, 5 minus 6. So that's negative 2 times 1 times negative 1. So it looks like it's positive 2 is my y value. So let's go ahead and graph everything. First, we have the intercepts, 4 and 6. And then my axis of symmetry is at x equals 5. And my vertex at 5, 2. Okay, again, now that we have the vertex, we can go ahead and follow our pattern of points. Here I'm going down because it's negative. Again, normally I'll go with 1, 3, and 5 because we have a 2. We're going to multiply each of these by 2. So we're going to graph these. So then we went down 2, which is where the intercepts are. And then let's go down 6. And there it is. Okay, so everything else should be pretty straightforward. But I do want to talk about this one as well. The second page, so this equation, again, h of x. Now this is also written in intercept form, but the tricky part may be this x here. So it might be easier to think of this as an x minus 0. Because if you think about it that way, then our x-intercepts will be at 0, 0, and 8, 0. And then to help us find the axis of symmetry, let's add up those values. And we should get 4. 0 plus 8 over 2 is 4. So then our x value of the vertex is 4. And again, to find the y value, let's go ahead and plug it in into the equation. So I have negative 1/2 times 4. And then times 4 minus 8. So negative 1/2 times 4 times negative 4. That looks like positive 8. And there it is. once again, let's go ahead and graph everything that we found. 0, 0, 8, 0, and then 4, 8. Axis of symmetry. And again, from the vertex, here's our normal pattern of points. But because we have a 1/2, let's take each of these divided by 2, cross those out. So let's go down 1.5, or down 0.5, and then down 1.5, and then we'll go down 2.5, and then actually 3.5. This will be down 7, and then down 3.5 will get us at the intercepts. And there it is. And there it is. Okay, so that's pretty much it for all of the graphing ones. I did want to talk about a couple of the key features as well. So let's see. Let's take a look at this one with the y-intercept. Okay, so we talked about how we can find the x-intercept. This, by the way, is in intercept form. Right, so to find the x-intercept, we'll set y equal to 0. So then on the other hand, to find the y-intercept, we're going to set x equal to 0, as we did before. So let's go ahead and plug in 0 for x. So I get 1/2 times 10 times -4. 1/2 times 10 is 5, times 4 is -20. So there it is. Our y-intercept would be 0, -20. And then let's also look at this one right on the bottom here, g of x. Here I'm looking for if the graph has a maximum or a minimum. Okay, so we did talk about that last week. Again, what you want to look for is you want to look for the shape of the graph. So if my parabola opens upward, then I'm going to have a minimum. But if my parabola opens downward, I'm going to have a maximum. Okay, so how do we tell if our parabola opens up or down? Well, we know you want to look for the negative sign. So if you have a negative coefficient in front, we know our parabola is going to be opening downward, which tells us that we're going to have a maximum. So then to answer our question, where our parabola will have a maximum. Okay, and then let's also talk about briefly about how we can write the equation of a parabola. So let's take a look at the one on the right, actually. So I want to write this in both vertex form and in intercept form. So let's start with vertex form. Well, where's my vertex? Vertex is right up here, -2, 9. So let's see. So if it's to the left 2, I know I'm going to need an x plus 2 squared, and an up 9, I need a plus 9. And then notice how our parabola is opening down, so I will need a negative sign in front. And then if we look at the points, so here's a couple other points here. So we're going down 1, and then down 3, and then down 5, which means our coefficient here is just a 1. You don't have to put the 1, but you could if it helps you, because again, it's not something else, because these are the patterns of points. And then to find the intercept form, we look for our x-intercepts. And looking at the graph, we see that it's going to be at -5, 0 and 1, 0. So then again, going back to our equation, we know we're going to have an x plus 5 and an x minus 1, because these will get us the intercepts of -5 and +1. And again, I need a negative sign in front, and the 1 is optional. All right, and then finally, the last section is asking us if each relationship is linear, quadratic, or exponential. Again, let me just kind of talk about how we can tell which one is which. So linear, we did that in semester 1. That's if as x changes by a constant, the first difference in y is constant. And then quadratic was what we talked about yesterday. So that will be second difference constant. And then finally exponential, we talked about that earlier in the semester. So that's when as x changes by a constant, y is multiplied or divided by a constant. Okay, so we can look at a few examples here as well. So let's look at the first one. So our x is going up by 3 each time. And then our y, I'm going down 2 here, down 2, down 2, down 2. Okay, so we see that the first difference is already constant. So that tells us that this is going to be linear. Okay, and then let's go ahead and look at maybe the one right below it. We have +2 for the x's. And then for the y, I'm going, let's see, this is +20, it looks like. This is 44. Let's see, this is 45, 68, it looks like. And then finally, I think this is going to be 92 plus 92. So the first difference we see is not constant. So then let's look at the second difference. So from 20 to 44, I'm going +24. 44 to 68 is 24. And this is also 24. So we see that the second difference is constant, but the first difference is not. So then that tells us this is quadratic. Okay, and then let's maybe look at the one to the right, just so we can see an example of an exponential relationship as well. So x is going up by a constant, going up by 1. But if you look at the y's carefully, you'll see that looks like we're dividing by 4 each time, or multiply by 1/4. So if our y value is being multiplied or divided by the same constant each time, we know the relationship is going to be exponential. Okay, so again, that's pretty much it. There's really nothing new, but just really a review of everything we did over the last couple of weeks. And thanks for watching.